Alrighty, so this is the 8-2 Trig Ratios notes. So we are moving on to Chapter 8 and also on to Trig. So, in our lesson today we're going to find sine, cosine, and tangent of an acute angle. That's because in any of our triangles that we're talking about, we always have a right triangle with trig. And then if there's a right angle, then the other two have to be acute. So, anyway. And then we're going to use the trig ratios to find side lengths in right triangles. Again, we talked about why they are, to solve real-world problems. Sweet. Okay. So, our trig ratio is a ratio of two sides of a right triangle. So, when we talk about sine, for instance, if I'm going to take the sine is like an operation. If I take the sine of this angle, standing right here, it's going to be of the opposite leg. Okay, so across from the angle that I'm talking about, in a fraction with the hypotenuse, which is always going to be across from the, whoops, let's spell that, hypotenuse. It's always across from the right angle. Alright, and then from there, if we're again still talking about angle A, this is what we call the adjacent side, right next to it. So something is adjacent to another item, those things are very right next to each other. So usually when I go through a triangle and label each of my pieces, I always start with what angle are we talking about, and in each of these we're talking about tangent or cosine or sine of angle A. And then from there I talk about, well, where's the hypotenuse, okay? And then which one is it touching? That's the adjacent. And then that last piece is your opposite. Because sometimes the opposite is a little hard on a triangle to identify. So always talk about the hypotenuse, and then the one that's coming out of the angle as well, which would be adjacent, and then opposite. Another thing that we're looking at here is that each of these is capital letters, right, for our angles. But it turns out that side lengths are given as the opposite angles lowercase letter. So B, and then B is opposite A, and lowercase a is opposite, and angle C and lowercase c is opposite. So they do kind of have this match. The other piece about this is that we tend to use a phrase or a word to help us out with this. And so if you remember it, and yes, it is weird and it doesn't actually mean anything. If we think of sine and the fact that it's opposite over hypotenuse, so sine is opposite over hypotenuse, and then cosine is adjacent over hypotenuse, and the fact that tangent is opposite over adjacent, we end up with a word that, yes, you will end up saying a lot, and people will actually know. Pretty much everyone knows this if they learn trig, which is Sohcahtoa. So if you remember the phrase Sohcahtoa, then you remember which fractions equal your sine, cosine, and tangent. So here we are with sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So what does that mean? Let's look at it over here. So we're going to find the trig ratios, which just means the trig fractions. And so we're just going to identify what number over what number is going to equal the ratio of that angle. So sine of j means that I'm standing here. And as I do with all the rest of them, I'm going to go through and label all the sides before I get to what sine actually is. So for instance, if we're standing at j, this is our hypotenuse, because it's across from the 90-degree angle. This one here is our adjacent, because it's also coming out of the angle that we're talking about. And then this one over here is our opposite. You'll notice that these two are trying to be of j, and tangent is trying to do k. So we will have to switch some things around when we get to k. Alright, that means that sine of j is supposed to equal the opposite side over the hypotenuse. And again, I could remember that by looking back at this page where it says opposite over hypotenuse, or I could remember because of Sohcahtoa, so I've got the O over the H. So then to solve this, all I need to do is fill in the opposite with the number it is, and the hypotenuse with the number it is, and of course reduce the fraction if I can, which I can't. 60 divided by 61 doesn't get reduced. And then give the decimal to the nearest hundredth, and hundredth is actually 2 places, so 0.98. Alright, then the next one is cosine, and so cosine, again, of j, so at that point, is going to be adjacent over hypotenuse. And adjacent side is 11, and hypotenuse is 61. 11 is prime, so that can't reduce anymore, but 11 divided by 61 to 2 decimal places, or the hundredths, is 0.18. Alright, now the problem with tangent of k is that if we're now talking about the angle k, this is no longer the opposite side, right? Because it's next to the angle k. So anytime that you switch angles, you end up switching your adjacent side and your opposite side. So now that we're talking about k, tangent is still opposite over adjacent. Again, from either TOA from Sohcahtoa or from this fraction written here. And so our opposite in this case is now 11, and our adjacent is 60. And then that as a decimal to 2 places is 0.18. Alright, so again, you have to switch what's opposite and adjacent if you are going to switch what angle you're kind of standing at or positioned. Alright, so next thing is the same, only now we're doing, of course, different numbers. You'll notice again that down here they start to use B instead of angle A. So as we set up, always remember that little phrase unless you want to reflect back on the fractions that were written in the notes here every time. But instead we'll just visit Sohcahtoa. Again, for cosine of A, that means that this is my hypotenuse. Over here is my opposite, and then coming out of A is my adjacent. Alright, looking at that, that means that cosine as it is adjacent over hypotenuse. And so that means that the adjacent of 24 is over the hypotenuse of 25. That fraction can't be reduced, but we can get our decimal of 0.96. Alright, then we're going to be talking about B now, and so because we're going to be on B, this is no longer my opposite, it's my adjacent, because it's coming out of angle B, and this is no longer adjacent, it's the opposite. So depending on what angle you are set at, A or B, your opposite, of course, is going to change, because it's no longer opposite, it's adjacent, actually. So tangent is opposite over adjacent. And so our opposite is 24, and our adjacent is 7. Of course, that doesn't get reduced, but 24 over 7 could become 3.43. And then our last one of sine. Sine is opposite over hypotenuse. And opposite is 24 and hypotenuse is 25. So that's 0.96 just like above. Alright. So just an idea of why trig is important is because once we get through these kind of setups and learning how to use cosine, sine, and tangent to set up, we can then end up solving a right triangle without two side lengths. We could solve a right triangle with an angle and a side, or two angles. Well, we need a side. So the idea is that we're getting away from a squared plus b squared equals c squared, because that means that you need two side lengths, and we don't need two side lengths anymore. We only need one. All right, and so when we're calculating trig ratios and using our calculator, you do, and rounding to the nearest hundredth, for instance, if you're going to type in sine of 52 on your calculator, you are going to type in the sine button. It's there in the middle. And then you're also going to type in 52 and your parentheses. The caution with this is that you need to be sure your calculator is in what we call degree mode. So how would you know what mode it's in? You click the button that says mode. It's up there at the top. And you're going to not have radian. Radian is your numbers 0 through 2 pi, but our degrees are 0 through 360, right? So we want to have degree selected. Because otherwise you're saying 52 radians, which we're not. We're saying 52 degrees, and so we want to make sure we're in the right mode to get that result back out. You'll tend to get some very interesting values if you are in radian mode, so you'll be like, what? I just typed it in, but that's so weird. And that's because you forgot to put it in degree mode. So, for instance, in radian mode, if I calculate sine of 52, I get 0.98 instead of 0.7. So that one's not as weird, but sometimes you'll get negative numbers, and you're like, what is this? So, again, it's because you're in the wrong mode. So, the next thing that we are going to do is find one of our lengths. And so, in order to find our length of BC, if this was a traditional problem, we would have said, oh, well, a squared plus b squared equals c squared, but notice that we don't have two side lengths. We only have an angle and a length. And so, because of that, we are going to end up just using trig. So, we have to identify which trig to use, and then we have to set up and solve. So, for instance, I'm going to have this as kind of my home base angle. Why? Because it's given as its degree measure. Potentially I could find this degree measure because I can subtract from 180, but use the given angle as where you're starting. From there, I know that this is my hypotenuse, because it's across from the 90-degree angle, and I know that this is my adjacent side, because it's, again, coming out of the angle that we're setting up at. And then over here is our opposite. So, from that, I am not interested in the hypotenuse, right? I have a measurement at opposite, and I want a measurement at adjacent, which is BC. And so I'm not going to use hypotenuse. So if you're thinking about which trig to use, I am not using the ones that have hypotenuse in them. So I'm not using that one, and I'm not using that one. And so I know that I'm going to solve this problem using tangent versus Pythagorean theorem. So that means that I know it's tangent of my degree, and that's going to equal opposite over adjacent. Just as we had over here, we set it up that sine of the angle is opposite over hypotenuse. You're just filling in that fraction, that function. So I'm going to fill in tangent of degree 15 is going to equal my opposite, which is 10.2, over my adjacent, which is BC. I don't know what it is. Alright, so in order to solve this, hopefully you can see that this looks very much like a proportion, and so we're going to use proportions to solve. For instance, I'm going to take tangent of 15 and multiply it by BC. And that's going to equal, 10.2 times 1. So the right side doesn't look weird, just 10.2 times 1, okay. But the left side does. So instead, we're going to, in degree mode, take the tangent of 15, and that is 0.26, or 27. And so now, hopefully, to find BC, since that's multiplied by 0.27, we're just going to divide by 0.27 to both sides. And from there, we'll be able to say that BC equals 10.2 divided by 0.26. Now, I did actually divide it by I divided by the actual decimal, because this, of course, goes on forever. So I'm going to get 38.07 as my length of BC. So, in order to solve a problem, you identify where the angle is, you identify what the name of the value you have is it opposite, adjacent, hypotenuse, find out what the name of the side you're trying to find is, pick which tangent, cosine, or sine you're going to use based on what you have and what you want, and then you get to solve. Over here, just a reminder, do not round until the final step of your answer. So that's why I got 38.07, but if you did not round, you probably got, or if you did round, you probably got 37.7 repeating. So, again, I actually continued to use, instead of 0.27, I ended up using 0.2679, etc. Because I wanted to make sure it was as accurate as possible. And you can see that they're, in fact, even different whole numbers. So it's best to use as many decimals as possible in your calculation. Alright, so the next one here, we're going to find the length and round to the nearest hundredth. So it's the same idea as before. I'm going to identify where my angle is. It's right here. Based on where my angle is, this is the hypotenuse. It's across from the 90-degree angle. This one is the adjacent side coming out of it. And therefore, this last one is the opposite. They want us to find QR, and so we're not actually using the adjacent side because hypotenuse has a number, and opposite is what we want to find. So identifying in Sohcahtoa which trig identity do we want? We want the one that has to do with opposite and hypotenuse. So opposite and, adjacent, no. This one doesn't even have opposite in it, so we're looking for sine. So it's sine of the degree measure is equal to the opposite side length over the hypotenuse side length. So filling that in, that means that we're going to have sine of the 63 degrees they gave. That's going to equal the opposite side length, which is known as QR, since we don't know it, over the hypotenuse, which is 12.9. Again, solving this like a proportion. If I cross multiply, I'm going to get QR times 1, and then sine of 63, times 12.9. So to simplify, my left side is just QR, but my right side is sine of 63, again in degree mode. So 0.8910 times 12.9. And so I can evaluate this number by multiplying. And I get a length of QR equal to 11.49. Alright, and so those are the ones that do take up the most time, because you are going to end up, other than setting it up, which was the other problems, you're going to actually have to take the time to solve that setup equation. So your assignment is going to ask you to solve for side lengths. It's also going to have you evaluate some values by plugging them in degree mode, and then it's also going to have you give some ratios of some trig. Alright.